Okay, in this video we're going to look at domain and range of some graphs again. We're going to go in a little bit more detail than last time. So I pulled some graphs off of Google, and if you look at this graph, it's a graph of temperature in New York City. It's a little fuzzy, but you should still be able to see it. And on the independent axis here I have days. So it goes 1, 2, 3, 4, 5, 6 days on the independent axis, and I labeled that axis D. On the dependent axis, this is degrees in Fahrenheit. So this is the temperature in degrees in Fahrenheit. So I labeled that in F for Fahrenheit. So domain, well, if you remember, domain is for the independent axis. So these days right here. So the notation I'm going to use is I'm going to use a set notation. I'm going to put D down to let us know what variable we're using. And we're going to say, okay, well, we see the domain is from 1 all the way to 6. So that's how I'm going to express that. The days go from 1 to 6. And this is a D, which was my variable. Okay, the range. Same thing, I'm going to use this notation. Now the range is the dependent variable. So I'm going to put F. And now if I'm looking at the range, I'm going to take my lowest value, which is 43. It's my lowest value. And it goes all the way to my highest value, which is 67. So that was the range of the temperature. It was from 43 to 67. Now notice that the 43 is first. It could have dropped down below 43 on day 3, and then that would be where my range is from. But it's your lowest value to your highest value. And we can write it in this set notation. Alright, let's look at another example. Okay, again, we have our domain and range on this graph. It's wavelength on the independent axis, absorption on the dependent axis. So let's label this A, and let's label this, we'll actually give this the wavelength symbol, so Greek symbol. And if we come down here, well, domain has to deal with my independent axis, so I'm going to use my set notation. I'm going to put that variable, my wavelength variable, and we're going to see that it comes, the lowest value here, we'll say that's right around 400. So 400 is less than or equal to, and it's equal to because this is a closed dot. We're saying that it's equal to at that spot my wavelength, which is less than or equal to, and we'll come over here, and that looks like 650. Alright, let's do the range now. So range is my lowest value to my highest value, but now we're going up and down. So my lowest value, let's set it up. So my set notation. Now we're dealing with A for my variable. My lowest value right here, well, that corresponds to 0. So we're going to say 0 is less than or equal to. And now we have my absorption variable. And what's the highest point? Well, the highest point is not right here, it's right here. So we have to look at what that equals to. And we're going to say, let's split that, it's about the 1.1. So we'll say 1.1. Alright, let's look at another example. And these are a little bit different, which if you see graphs like this, functions like this, a lot of times you can assume that they are continuing forever. So this linear line, I know we've done this before, linear line, it goes forever to the right and forever to the left. So to make this simple for our class, we're going to say that since it goes all the way to infinity and from negative infinity, we can just state that as all reals. The range, again, it goes from down from negative infinity up to positive infinity, so this is all reals. All real numbers. Let's look at this graph. You should recognize this graph as an absolute value graph. Let's say that that's negative 1. Well, the domain, it goes forever to the left and forever to the right. So my domain here is again going to be all reals. My range, though, however, is different. So we'll call this the y-axis. And if we look at that set notation, we're going to say that the lowest value is negative 1, so therefore y is greater than or equal to negative 1. And that represents everything else. Now on this is a sinusoidal wave, and we can assume that this keeps on going in this rhythm. So this wave will continue going, oscillating back and forth like this. So for our domain, it's going forever to the left and forever to the right. So this is all reals. And our range, let's give this 0, and let's say this is 1. So our range is going to be y, and that is in between 0 less than or equal to y less than or equal to 1. And down here, this is a function which we can't really see the full function. So in this case, let's eliminate this one and say there's not enough information. We could evaluate the domain and range for what's inside here, but we're not sure if this approaches an asymptote or what this really does. So let's not look at this one and say there's not enough information for what we're given. Info. Okay, so that should give you a good idea on how to find the domain and range for graphs, and we'll keep practicing this throughout the class.